Hi everyone. So in this video we are going to see the solutions of all India scholarship test 2. So just now you guys have completed your scholarship test. So let's see the solution. I hope you guys have given a fair attempt. So let's get started. First we need to analyze this particular circuit, and in this particular circuit I have asked a few questions like V01, V02, V03. We just need to comment on V01, V02 and V03. This is what I have asked. So these are the questions, but first let's analyze this circuit. Let's see what is happening in this particular circuit. So there is a current source, then there is parallel RC, then there is only capacitor C, and then again there is parallel RC. So what do you think what is happening in this circuit? From here the current I in is going, right? This is the current I in. Now this current I in has two paths. It can go into C1, it can go into R1. After that, let's just say from this is your I in. Now let's just say this current is I1 and this current is I2. What I am saying? This current is I1 and this current is I2. Now I1 and I2 will be added. So again here how much current will be flowing? Again I in current will be flowing, right? I in came from here, divided into two parts, then again I in current is flowing. Now here also there is I in current. Now this I in current again have two paths. Let's just say this is I3 and this is I4. Are you able to understand this point? I in divided into two parts, again added back, again I in, and then again divided into two parts. So what do you understand from this? That in C3 capacitor, there is always I in current, always, no matter whatever the condition is. In C3 capacitor, always there is I in current. No matter whatever the voltage is here, no matter whatever the voltage is here, no matter whatever the voltage is here, C3 capacitor is always driving I in current. So what I need to find? V03. So if there is a constant current in the capacitor, then what will be the voltage? That would be 1 by C3 integration I dot dt for any time limit t. Right? The current is starting from 0, 5 ut. This is step. So the current is starting from 0. That means I will put the limit from 0 to t. So what is the value of C3? C3 value is 1 only. C3 value is 1. So it becomes I dot dt. What is I? I is 5. 5 ut. 5 dot dt. So current would be 5t into ut. This would be the current. Basically, this 5 ampere will charge the capacitor linearly. This will charge the capacitor linearly. So this is the equation of V0 3t. What they are asking? They are asking the value of V0 at t equals to 2 seconds. So what will be the value at t equals to 2 seconds? That would be 10 volt. There you go. So the important part was C3 is driving a constant current. Let's analyze this particular part now. Let's analyze this part. So what do you think what is happening here? At t equals to 0, initially, there is no charge on the capacitor. C1 is having 0 voltage. So this guy is providing a short circuit path, right? C3 is shorted. So what I in will see? That initially this is providing me 0 impedance, or it is shorted. So I will completely flow from this part only. What I mean to say is that I1 at t equals to 0 plus would be equals to I in only. Look guys, this is not the case of infinite current. If there was a voltage, then it would have been the case of infinite current. Okay, those who have studied in a good manner, they would know what I am talking about. So this is not the case of impulsive current. Impulsive current would have flowed if here there was voltage source, but this is a current source. If I ask you this question, and I ask you what is the current here, you would say it is I in only. Why is that so? Because no matter whatever the voltage is there across the current source, it will always drive I in current. So current can flow from short circuit path. But if I ask you this question, what is the current here? There is 0 impedance, V divided by 0. So you would say that, sir, there is impulsive current, or you can say there is infinite current. But this is a current source, this is not a voltage source. So this is not a case of impulsive current. In this particular circuit, this 5 ut current is flowing. So this is not a case of impulsive current. Okay, those guys who have studied in a good manner, they would be getting confused that, sir, why impulsive current cannot flow? Impulsive current cannot flow because the current is fixed here. That's it. Okay, so at t equals to 0 plus, the current is I in. Now I in current has flown from here. Basically 5 ampere current has flown from the capacitor C1. So capacitor C1 has derived 5 ampere current. Now if there is some current flowing in the capacitor, what it will do? It will develop some voltage. Let's just say it has developed 0.00001 volt. If there was some current, so capacitor would have developed some voltage. Now that voltage will be exposed to resistance R1. 0.0001 because they are in parallel. The same voltage has been exposed to R1. So if there is some voltage on resistance, if there is some voltage, what it will do? It will drive current. So that means resistance R1 will start driving some current. So at t equals to 0 plus, the whole current is flowing through C1. At t equals to 0 plus, the whole current is flowing through C1. Because of that current, the capacitor has developed some voltage. Now that voltage has been exposed to resistance R1, and because of that voltage, R1 has started driving some current. Let's just say this R1 has driven 1 ampere current. Because of this voltage, R1 has been driving 1 ampere current. So from here 5 ampere current is coming, 1 ampere current is going in R1, so rest 4 ampere current is going into capacitor C1. Now because of this 4 ampere current, the capacitor is increasing its voltage. Now let's just say the voltage has increased to 0.2 volt. Now this 0.2 volt is exposed to R1 again. Now in place of this, there will be 0.2 volt. The 0.2 volt is exposed to R1 again. Now what will be the current R1 will be driving? 0.2 by R1. Initially how much current it was driving? 0.001 divided by R1. So now the current has increased. So basically what is happening is that slowly the current in R1 is getting increased. Why is that so? Because initially whole current was flowing through capacitor C1. Because of that, capacitor developed some voltage. That voltage is exposed to R1. R1 is driving some current. Now lesser current is flowing in C1, but still there is some current. If there is some current, that means voltage is increasing. If voltage is increasing, the increased voltage is exposed to R1, and because of that, R1 is again driving some current. So slowly the current is increasing in R1. Why is that so? Because voltage is increasing across C1. If the voltage across C1 increase, the R1 will drive more current. So initially it was 1 ampere, then it will go to 2 ampere. Highest it can go to 5 ampere, right? So when R1 drives 5 ampere current, at that time what will be the current in capacitor C? When R1 is driving 5 ampere current, what will be the current in capacitor C1? That would be 0 ampere. When R1 is driving 5 ampere current, the capacitor C1 will take 0 ampere. What does that mean? The capacitor C1 will be open circuited. So this is the condition of steady state. So at steady state, capacitor C1 will be open circuited. Why is that so? Because the whole current will be taken by R1, and if R1 is taking whole current, then capacitor C1 is open circuited. But what we study, like initially capacitor will be shorted, and at steady state capacitor will be open circuited. Why it will be open circuited, that I am telling. It will be open circuited because complete current is taken by R1. Now if there is no current in the capacitor, that means there will be no further charge. If I say across this capacitor C there is 0 current flowing, so there will be no charge on this capacitor, right? Whatever the charge it has developed, it will be there only. If there is no current, then there is no further charge on the capacitor. That means that is the steady state. So steady state is when C1 is driving 0 ampere current. That means the whole current is taken by, let's remove it off completely. The whole current is taken by resistance R1. So initially at t equals to 0 plus, what would have been the value of V01? So V01 at t equals to 0 plus would have been 0 volt, because the whole current was flowing through capacitor C1 and capacitor was shorted. V01 at infinity, what it would have been? The whole current is flowing through this R1 resistance. The value of R1 resistance is 2 ohm. So 5 into 2, that means capacitor would have developed 10 volt. Because if capacitor has developed 10 volt, that means 10 by R1, R1 value is 2. So 10 by 2, that means resistance R1 is driving 5 ampere current. So the complete current which is coming from the battery, the whole current is flowing through resistance R1. So this is the value of V01. At t equals to 0, it is 0 volt, and at t equals to infinity, it is 10 volt. Is it first order or second order or third order? You see 3 capacitance here, so does that mean it is third order? No. In the charging of capacitor C1, how much in the charging of capacitor C1, which role you could see? Only the role of C1 you could see, no? Like there was no role of C3. No matter whatever the voltage was here, there was no role of C2 and C3. In the charging of C1, there was only the role of C1 only. It is a first order circuit only. Or how you can see, across C1 resistance, how much impedance do you see? Look, what is the first task? First task is, when I calculate the order of the circuit, first task is I need to make it open circuited. The current source will be open circuited, current source will be nullified. Now across resistance R, how much capacitance do I see? Only C1. Why is that so? Because across R1, this part is open circuited, no? If I apply a battery here, so where will the current go? Can the current flow in this path? No. Can the current flow in this path? No. Everything is open circuited. if I open circuit this path, that means this path is also open circuited, no? If I apply a battery here, then the battery, then the current will be flowing through C1 only. So across R1 you only see C1, that's it. If there was a voltage source here, if there was a voltage source, then the scene would have been different. Because if there is a voltage source, what does that mean? That voltage source will be shorted. So if I apply a battery here, the current can flow through C1 as well, the current can flow through these elements as well. Then the scenes would have been different. Then I would have to analyze it. But as of now, there is a current source. I don't need to analyze it. Are you able to understand this point? Okay. So only this question I am explaining with good amount of patience. Rest all I will solve quickly, because all these concepts have been delivered in our videos. Okay. If you have studied from some gods do not teach this thing. Human does. Okay. But god people, if you have studied from god people, then they might not have taught you all these kind of things. But human does. So in humans playlist, this is there. Okay. And human on PrepFusion, only humans teach. No god teach here. So that's why, like, only first problem I am solving with good amount of patience, good amount of understanding. Otherwise, all the concept have been delivered. If I solve again completely, then it would take a lot of time. Already this only this solution is taking 12 minutes of time. So yeah, let's get started. So this is the first order circuit. So can I write down the equation of V01? Yes. What will be the equation of V01? V01 would be 10 into 1 minus e to the power minus t by tau. What is the value of tau? Tau is R1C1. What is the value of R1C1? R1C1 is 2. What they are asking? They are asking the voltage at, oh, it will be nearly around 8. Yeah, 8.65 I guess. Nearly around 8.65. Or you can do the calculation. This will be the V01. So they are asking about V01 value at t equals to 4 seconds. What they are asking, considering V02 as the output and In as the input, find the time constant of the circuit. Yeah. So whatever the thing that I explained here, whatever the thing that I explained for R1C1, the same thing will be happening with R2C2 as well. Whatever that I explained for R1C1, the same thing will be happening for R2C2 as well. Why is that so? Because the same thing will be happening here, no? In current will be divided into two parts. Then this current is In. Now this current In is having two paths, whether to flow from R2 or to flow from C2. So at t equals to 0, capacitor is shorted, so the complete current will be flowing through C2. Because of this current, the capacitor would have developed some voltage. Now this voltage is exposed to resistance R2. That means R2 will drive some current. Now from here 5 ampere current was coming. R2 has driven some current. Let's just say this current is 1 ampere. Now 4 ampere current is flowing through the capacitor C2. Now because of this current, more voltage will be developed here. More voltage will be developed here. That means this voltage will be exposed to resistance R2 again. Now because of this more voltage, this resistance R2 will drive more current. Let's just say this is driving 3 ampere current. Now 5 ampere current is flowing from here. 3 ampere current is going in R2. That means now the capacitor C2 will drive 2 ampere current. So slowly the current in the capacitor C2 is decreasing. Now it will keep on decreasing and it will go to 0 ampere. So at the time when C2 is driving 0 ampere current, at that time R2 will drive 5 ampere current. So complete 5 ampere current will be flowing through R2. Now because of this 5 ampere current, what will be the voltage developed across R2? That will be 5 into R2. And the same voltage will be exposed to the capacitor C2 as well. So capacitor C2 has developed its voltage from 0 to 5 into R2. There you go. And this charging will be exponential. Why is that so? Because across C2 you only see R2 resistance, or you can say across R2 I only see C2 capacitance. So what will be the time constant? Time constant will be R2 C2 and the order of the circuit will be first. So time constant R2 C2, that means time constant will be 2 seconds. Along with that, if I ask you, if you consider V03 as your output, V03 as your output and In as the input, basically your transfer function is V03S divided by INS. Then what is the order of the circuit, or what is the time constant of the circuit? If I am considering V03 as my output and INS as my input, so tell me what will be that time constant of the circuit. What is the equation for V03? That is 5t ut, right? This is the graph of V03, right? This is the graph of V03. What does the time constant show? Time constant shows that within this time you will reach the steady state. Basically for this particular graph, time constant will be finite. Time constant will be non-zero and finite. For this particular graph, time constant will be 0. Why is that so? Because immediately you reach to the steady state. So here time constant will be 0. Here time constant will be non-zero but finite. But if I say this is the graph, that means voltage will keep on increasing. It will never reach at the steady state. So what will be the time constant? Infinity. and you can check as well. Across V03, across this C3 capacitance, what will be the effective resistance? Across this C3 capacitance, what will be the effective resistance? What you will do? You will open circuit this. Now you will apply a battery here. If you apply a battery here, forget about C3 now. You need to see the resistance. Will there be any current flow? No. This is an element, right? There is some element. Then there is a battery. Then there is a battery. And then again there is some element. Again there is some element. But this part is open circuited. This part is grounded. You can take this part as grounded. But this part is open circuited. Basically, if I make this particular circuit, there is some element. Then there is voltage source. Then again there is an element. This part I am keeping as grounded, and this part is open circuited. What do you think? How much current will flow from the battery? 0 ampere, no? Right? 0 ampere. Because there is no closed path. If there is no closed path, that means there will be 0 current. If current is 0, that means what is the resistance? Infinity. So what is R effective? That is infinity. So what will be the time constant? Infinity. Because time constant is R into C. R is infinity. That would be infinity only. So this I have seen in a lot of notes. I don't know why. That they will ask you what is the time constant of the circuit. This statement is wrong. What is the time constant of the circuit? No. The time constant is defined with respect to output. Here I have defined 3 different output. V02, V03 and V01. So now I need to tell V03 is your output and In is your input. Tell me the time constant. What you will say? What is the time constant? Infinity. If I ask you V02 is my output, In is my input. What is the time constant? R2C2. If I ask you V01 is my output, In is my input. What is the time constant? R1C1. Okay, like in 100% of the notes except from PrepFusion, in any coaching you would see they have written what is the time constant of the circuit. Doesn't make any sense at all, right? Needless, absolutely rubbish, no concept there. So you need to define the output, you need to define the input as well. Then you need to tell me what will be the transfer function. With respect to that, I will tell you the order of the circuit. So across C3, 0 order. Across C2, first order. Across C1, first order. Across C3 I would not say 0 order circuit. It is not 0 order circuit. It is actually, order will not be defined here. I cannot define the order of the circuit here. If I take my output as C3, that means if I take my output as V03, then I cannot define the order. But for V02 and V01, I can define the order. I can tell the time constant as well. For V03, the time constant will be infinity. So this was the solution of first question. I hope you have enjoyed the solution. I hope you have enjoyed the electronics here. Okay. So this is how the electronics is taught. This is the meaning of electronics. Now those who are looking at this platform for the first time, they would be thinking what it is. But those who have already seen it, then they would know what it is, right? So not being arrogant, just letting you know the value of this platform. That's it, nothing else. Okay. Yeah. Then in this question they have asked the value of a time constant. So this is the time constant. Well and good. Let's go to the next question. So let me take a pause, then I will solve this question, or you try it on your own. Again the same thing I have asked. V01 as the output, or you guys have already tried it, so there is no meaning of taking a break. So let's start solving again. So V01 is the output, I02 is the output. So 2 kind of output I am defining here. Vin is the input. So what they are asking? First they are asking the order of the circuit, and then they are asking the V0 value at t equals to 1 second. Okay. Order of the circuit, a very, very important and a very, very interesting circuit it is. If my output is V01, here I am considering my output as V02. Okay. If I give V01 voltage to this particular inductor, then what will be the voltage across V02? So V02 will be Vin minus V01. So basically one independent voltage I have to give. If I am giving one independent voltage to this particular inductor, then this inductor is not having independent voltage, this is having dependent voltage. Why is that so? Because Vin I already know, and this voltage I have given, that means this voltage also I know. So if I know the voltage across 2 Henry, that means surely across this 2 Henry I already know the voltage. So how many independent variables are there? Only one. This will user apply. One independent voltage I have to give from my own side. So only one independent voltage is there. That means with respect to voltage, it is first order. So here with respect to this voltage and with respect to this voltage, it is first order circuit. Okay. So with respect to voltage, like if someone says that V01 is your output, V01 is your output, then what is the order of the circuit? First order. If someone says that V02 is your output, then what is the order of the circuit? First order. Or what I could have said that this V02 I am giving, V02 I am applying from my own side. That means V02 is the independent voltage that I am giving. So what will be the voltage across this 2 Henry inductance? That would be V in minus V01. That means if, sorry, V in minus V02. So if I am giving this voltage from my side, that means this voltage is not independent. This is dependent only. It is depending on V in and V02. Are you getting this point? So that's why it will be dependent voltage. So only one variable I have to give. Have you studied state space analysis? In state space analysis, that is the topic of control system, we again introduce this particular topic. What is the meaning of independent variable? So only one variable I have to give from my own side. So only one independent variable is there. It feels like that there will be two independent variable, but there is only one. Okay. Like some people teach this particular concept by this particular thing, that you short circuit the input voltage and then you see that 2 Henry and 2 Henry are coming in parallel. So they are coming in parallel, so it will make 1 Henry. Okay, so it is a first order circuit. Absolutely wrong concept. It will be changing with respect to the current. Okay, let me tell you this thing. So it will change. This will work at 99% of the circuits, but in 1% of the circuit this method will fail. Which method? That short circuiting in the input side. So that is the 1% which I am asking here. Okay, although this is there in our class notes only. So yeah, let's check. So with respect to voltage it is first order, but what about with respect to current? Look, with respect to voltage it is first order. What does that mean? That V02S divided by V in S will be a first order circuit. AS plus 1. Can I write it down in this manner? It can have a zero as well. It can have a zero as well. It will have only one pole. What is the meaning of first order circuit? That it will have only one non-zero pole. Now it can have a 0 at infinity, it can have a 0 at some value, or it can have a 0 at 0 as well. So let's check. Okay, let's not check anything. Let's put the question mark sign only here. Okay, let's put the question mark sign only. What I need to tell? I need to tell the order. If I consider I02 as my output, what does that mean? That I need to find I0 as divided by V in S. This is what I need to find, right? If I am considering I02 as my output, so this is what I need to find. So what is your V02? That would be I02S into LS. L is 2 Henry here, divided by V in S. That would be equals to question mark divided by AS plus 1. Now this LS can come here, right? This LS can come here. So it is having a pole at minus 1 by A, and it is having a pole at 0 as well. So there are two poles. So now what is the order of the circuit? It becomes second order circuit. Are you able to understand this point? So with respect to the output, it is with respect to the current output, it has become a second order circuit. Second order circuit. But again there is a glitch. What kind of glitch is there? If I ask you this particular question, this is a very standard circuit, right? Forget about this ground. If I consider this is the output and this is the input, and the other output would be the current. If I ask you with respect to the voltage, what is the order of the circuit? What do you see? First order. And with respect to the current, as well, it is a first order circuit, right? This is what we say. We have seen it, right? What will be the I0 S value? You can find it out. It will be first order only, that's for sure. But if I apply the same concept here, what will happen? If I say with respect to voltage it is first order, what does that mean? This is what I mean. And from here, if I need to find the current, what that would be? I0 S into LS. Here I should not put 1. Here I should put question mark sign. I0 S into LS divided by V in S. So this LS can go to the other side. So what it will become? SA plus 1 into LS. So it should become second order circuit. It should become a second order circuit. But why it is first order? Because you did not talk about this question mark sign. In this question, what is happening? There is a 0 at omega equals to 0. What I am saying? There is a 0 at omega equals to 0. Here the condition was some B into S. So some B into S was already there. B into S, what is the meaning of B into S? B into S is equals to 0. That means there is a 0 at 0. There is a 0 at 0. So already here was BS. This BS was already there. So what really happened? S to S got cancelled. So effectively it became first order circuit only. There is only one pole because there was pole 0 cancellation. Pole and 0 was getting cancelled in this particular circuit. So in this particular circuit, when I was writing down this transfer function, there I noticed that it is having a 0 at omega equals to 0. But is this circuit is having a 0 at omega equals to 0? Is this circuit is having a 0 at omega equals to 0? No. This circuit is not having a 0 at omega equals to 0. Because if you put omega equals to 0 in this circuit, what will happen? At omega equals to 0, this will provide infinite impedance. Sorry, at omega equals to 0, this will provide 0 impedance and this will also provide 0 impedance. The whole circuit is being shorted. If the whole circuit is being shorted, that means the effective RL circuit will be replaced with L only. So what will be the value of V02? The value of V02 will be V in by 2. And what is the meaning of 0? The meaning of 0 means the transfer function should be 0. But at omega equals to 0, the V0 divided by V in is coming out to be 1 by 2. That means surely here B into S will not come. That's for sure. Look, all these are intuition which are built if you solve good level of problem and if you study from a good resource. Otherwise you will find out the transfer function, you will do the manual work. This is not engineering, but this is the engineering. Okay, and in one video it will be very tough for me to give all the concept, but in our lecture series I have given all these kind of concept. Although there are no high views, okay, there will be lakhs of views on easy content, but if there is something that will push your brain, that will have lesser views, and it is fine for me. At least I am having quality people, at least I am having quality students. So this is what I was teaching. What I was saying is that here whenever I write down this transfer function, I need to care about the 0 as well. That if I am getting a 0 at 0, then there might be a chance that this LS and this is getting cancelled. So it will become first order circuit. So my target was to check the 0. I got to know that it is not having 0 at omega equals to 0, because at omega equals to 0, this is being shorted, and at omega equals to 0, this is providing very less impedance, almost 0 impedance, and this is a finite impedance. So if two impedances are in parallel, this is very low and this is some finite value. So 100 parallel with 1 nearly will be equals to 1 only. So parallel combination of RL circuit at omega equals to 0 can be replaced with only L. Okay, so what it will become? Series combination of LL, series combination of inductor and inductor. So what will be the value of V02? V02 will be V in by 2. That means what is the value of transfer function? That would be half. So transfer function is not becoming 0, because at 0 transfer function should become 0. That means there is no term of BS here, and if there is no term of BS here, that means pole 0 cancellation is not there. If pole 0 cancellation is not there, that means this will exist. That means it will become second order. So with respect to current, it will become second order, but with respect to voltage, it was first order. So the value of B was 2. The value of B was 2. The value of A was 1. So 2 plus 1 into 2. 6 was the answer. If nothing clicks, write down the transfer function. But this is not my target. This is not something that, this is not the way I teach. Write down the transfer function. Anyone can do it. No, class 10 guy can also do it. Replace this with 2s, replace this with 2s, replace this with R. Write down the transfer function, do the manual work. But you are an engineer. Again, the same thing. You are an engineer. When you go to the industry, this is how the things are taught. There also in the industry as well, they will take classes, and this is how they will be teaching it. Even in the masters, if you do masters from a good college, this is how the things should be studied. Okay, not the Laplace and all these kind of things. Gods will teach you this thing. God will say that Laplace would work, whatever that we teach, everything would work. What these young guys would do, 23-year-old, they are my student, they are this thing, that thing. Okay, if I had been your student, then I would never be able to teach these kind of things. Okay. Yeah, send this video to gods if you are a devote of these gods. Okay, because people become god very easily. But humans will be there on PrepFusion. I will always be a human. Okay, because I know nothing, right? I know nothing. As of now, till this point, I know nothing. When I go in my 40s, in my 50s, then I might be knowing a few things. But as of now, these things are nothing. Okay. But God will always feel that they know everything. but they actually doesn't know even these things. So everything is too far away from them. What we need to find V01 at t equals to 1 second. So for V01 it is a first order circuit only, right? V01 it is a first order circuit only. So at t equals to 0 what will happen? This is having 0 ampere current, this is also having 0 ampere current. Initial current in the inductor is 0. If the initial current in the inductor is 0, that means it will be open circuited. So I will make them open circuited. So it will be open circuited and it will be open circuited. Okay, so what will happen? This V in voltage will travel here 0 volt, right? Let's make the circuit at t equals to 0. So inductors will be open circuited. So this will be the circuit. Inductors are open circuited. So this is the resistance. Then inductor is open circuited. So this is the scenario. Both are grounded, or you can connect them in this manner as well. So this is the 0 volt. If the complete circuit is open circuited, no, right? So at t equals to 0, how much current is flowing from this battery? 0 ampere. How much current is flowing from this battery? 0 ampere, no, because the complete circuit is open circuited. So what is the drop across the resistance? That is also 0 volt. The drop across the resistance is 0 volt. If the drop across the resistance is 0 volt, so here what is the voltage? V in. Here what is the voltage? V in. So what is the voltage drop across this impedance? Sorry, across this inductor. Basically this inductor was open circuited. Now in the whole circuit there is no current. In the whole circuit there is no current. So now there is 0 voltage drop across this resistance. So this V in will reach here only, because this potential is 0, this potential is V in, this potential will also be V in only now. So across this inductor there is V in voltage. Across this inductor there is V in voltage, but across this inductor there is 0 voltage, because this is V in, this is also V in. So V01 value will be 0. At t equals to 0, the V01 value will be 0. Why is that so? Did you understand this point? Here there is V in, here also there is V in. So what is the value of V01? V01 will be V in minus V in, that would be 0 only. So V01 is 0. What will be the value at t equals to infinity? At t equals to infinity. T equals to infinity means DC content. That means omega equals to 0. What is the meaning of t equals to infinity? T equals to infinity in a RC/RL circuit will show omega equals to 0. So at omega equals to 0, I have already told the parallel combination of RL can be replaced with L only. And if I directly make the circuit at t equals to infinity, what will happen? The inductors will be shorted. So if inductors are shorted, then what is the condition? This is the condition, that inductors are shorted. And then there is this resistance. If I ask you the value at this potential, so at t equals to infinity, what we will say? At t equals to infinity, this ground will say that the value should be 0 volt. And at t equals to infinity, this battery will say that this battery is V in. V0 should be equals to V in. So KCL, KVL is being violated. What I am saying, at t equals to infinity, the complete circuit is being shorted. The complete circuit is being shorted. If the complete circuit is being shorted, then V0 value at t equals to infinity will be equals to V in as per this battery. And what this ground is saying, that value should be 0. That means there is something wrong. And if there is something wrong, then we have studied that we need to come to this analysis. So I came to this analysis. So at t equals to infinity means 0 frequency content. A step function has all the frequency content from 0 to infinity. But at the jump, infinite frequency content is more valuable, and at steady state, 0 frequency content is more variable. This we have already studied. And in Fourier transform as well, I have again told this concept, that at t equals to 0, infinite frequency content is more valuable, infinite frequency content is more dominating, and at steady state, 0 frequency content is more dominating. So this I have already taught again in your Fourier transform course. But as of now, this I have already taught. So t equals to infinity, that means 0 frequency content is more dominating. So RL circuit, parallel combination of RL circuit will be replaced with L only, right? So it will be replaced with L. So what will be the condition? And this is alone, this guy is already alone. So this will be L only. So what is the condition? That there is a battery, $200 and $200. And what they are asking? They are asking the value of V01. So this is something they are asking. And this is your V in battery. So what will be your V01? V01 will be V in by 2. What is the value of V in? That was 550. So that would be 2.5. So what will be the equation of V01t? From 0 to it is going to 2.5. So 2.5 into 1 minus e to the power minus t by 2. What will be the value of tau? So across L you see 1 ohm. Is that so? No, absolutely wrong. Here what is there? Voltage source is there, no? So voltage source will be shorted. Voltage source is shorted, then what will happen? This 2 Henry impedance will come in parallel to this one. So total impedance across this 1 ohm resistance will be total impedance, or I should say total effective inductance will be 2 Henry parallel with 2 Henry, that will be 1 Henry. So 1 ohm and 1 Henry. So time constant will be L by R, that would be 1 second. So time constant would be 1 second. So here the time constant would be 1 second. And at 1 second only they are asking, so 2.5 into 1 minus e to the power minus 1. So it would be 63% of 2.5. So nearly 6.3 divided by 4. 63% will be 6.3 divided by 4. This should be the answer. So 4.5 something. Yeah. Roughly around this answer would be there. So 1.55 between. You can do this calculation basically. Just put this, do this calculation in your calculator, you will get the answer. I hope the concept is clear. I hope how the things are understood here, that is clear. But in one video, you cannot expect that everything will be taught. Transient analysis I have taught in 30 hours. In those 30 hours, you will actually get the quality content, not like equations and all these kind of things are not there. These kind of intuitions are there. So you should never ever avoid those videos at least. Okay. Yeah. So let's see this question, but let me take a pause. I will drink some water and then I will deal this question. Yeah, so let's solve this question. This is a easy question if you know the concept, otherwise it would be difficult. So forget about this particular question. I will teach you a concept here. Okay, I will teach you mathematics. So what I am saying that ft is equals to something maths I am teaching you. Forget about this question. We will come back to this question, but some good things I will be teaching you here. So what I am saying, ft is equals to d by dt of gt. That means differentiation of gt is equals to ft, right? So can I do something like that? That d by dt can go to integration. And one thing in signal system I taught you, if your differentiation goes to integration, then the limit will go from minus infinity to t. ft dot dt. That would be equals to gt. Say yes or no. Do you agree to this point? Now can I break down this particular thing in this manner? Plus 0 to t ft dot dt is equals to gt. So I am writing down first. Can I write down this value as g of 0? Can I write down this particular value as g of 0? G of 0 plus 0 to t ft dt. How did I write it down? Let's just say this is your ft. Let's just say this is your ft. This is your ft. This is your ft. Okay. Now what I need to do? I need to find gt. What is gt? gt is the running integration of ft. Basically gt is the integration of ft. Now what if I do the integration from minus infinity to 0? That means I am calculating this much area. And this much, basically I am doing the integration from minus infinity to 0. What is your gt? This is your gt. Minus infinity to t ft dot dt. This is your gt, right? If I put t equals to 0, what I will get? G of 0 will be equals to minus infinity to 0 ft dot dt. So minus infinity to 0 ft dot dt is equals to g of 0. Minus infinity to 0 ft dot dt is equals to g of 0. So this is what I have wrote. Is that clear to you? So basically, if your differentiation is defined in this manner, if this equation is given, then from here gt can be equals to g of 0 integration plus integration goes from 0 to t ft dot dt. So from here to here you should be directly able to write down this step. But a lot of people don't know this step, that's why I give you the derivation as well. Now what if your gt is periodic? What I am saying, gt is periodic with the time period t. With the time period t. gt is periodic with time period t. Okay. Now what I am doing, in place of t I am putting capital T. In place of t I am putting capital T. Is that okay for you? In place of t I have put capital T. Now if it is periodic with t, what does that mean? That g of t plus t would be equal to g of t. Now here if I put 0, what does that mean? That g of t is equal to g of 0. right? In place of small t, I put 0. So g of t would be equal to g of 0. That means both these are same. So from here, what did you get to know? Both are same. What does that mean? That gt minus g of 0 will be equal to 0. So what do you understand from here? That for one time period, if you integrate your ft, that integration will throw 0. Is that clear to you or not? So if this is the relation, then for one time period of gt, if you integrate your ft, then the answer would be 0. Now what about the capacitor and voltage equation? IC equals to C dvct by dt. In place of IC, I am having ft. In place of VCT, I am having GT. So can I write down this thing? That for one time period, if first thing is that my VCT should be periodic. If your VCT is periodic, then for one time period, your ICT dot dt should be equal to 0. If your VCT is periodic, then the average current, what do you mean by this? 0 to t IC dot dt. This is the meaning of average. If I ask you the average of a particular graph, what do? For one time period, you calculate the area and then you divide by the time period. And if the average is coming 0, that means there is no meaning of this t can go here. So what I can say, if my voltage across the capacitor, is periodic, then the average current through the capacitor will be 0. Again, let me repeat the statement. What is the statement? If my voltage across the capacitor is periodic, then the average current through the capacitor will be equal to 0. Is that statement correct? Absolutely correct. What I am asking? I am asking the value of, find the average value of V0 at steady state. Average value of V0. Now at the steady state, this capacitor voltage will be periodic. Why is that so? That I cannot teach you here. Basically, there will be two kind of analysis. Because of this 5 volt, you will get some DC voltage here. V0 value will be some DC. Because of 5 volt, at steady state, V0 value will be some DC. And that would be, if I consider this as shorted, I am not considering this V in voltage also. If this is shorted, so that voltage will be 2R divided by 3R into 5. So that voltage will be 10 by 3 volt. So that would be a DC voltage. But because of this pulse voltage source, so voltage will go this like this. Voltage will keep on going like this. Voltage will keep on going like this. So because of this voltage source at steady state, because of this voltage source, you will get a periodic waveform. The waveform will be somewhat like this. And because of this, you are getting a DC. So that means this waveform will be shifted upward. If I say xt is periodic plus I add a DC, so will this complete yt will be periodic or not? I am saying xt is periodic, and then I add a DC value. DC value will just shift up the graph. That means if xt is periodic, then yt will also be periodic. So same thing is happening here. Because of 5 volt, you will get a DC value. But because of this input, you will get a periodic waveform at the output. So at the output, you are getting a periodic waveform. That means across the capacitor, you are getting a periodic waveform. That means VCT here is periodic. What does that mean? The average current through the capacitor, at steady state. Because all these things, it is periodic at steady state. At t equals to 0, it is not periodic. Initially, it is not periodic. Initially, it is charging, discharging. But at some point, it will be saturated, or nearly it will give you a periodic waveform in this manner. At some point, at steady state. So at steady state, everything I am saying at steady state. So at steady state, my V0 value, or I can say the voltage across the capacitor is periodic. So again, I will write down the statement here, a very important statement. At steady state, VCT is periodic. What does that mean? The average current ICT is 0. So at steady state, the average current through the capacitor is 0. What does that mean? The capacitor will be open circuited. So at steady state, the capacitor will be open circuited. It is not the scene that there will be no voltage. There will be no current. The current would be there, but the value of average current would be 0. Can I say this statement that at steady state, the capacitor current is 0? Absolutely wrong. if there was a step function, if there was a 5 volt which is constant, then I could have said that at steady state the current through the capacitor is 0. But here there is pulse input, no? There is pulse input. So for the pulse input, you can never ever say that at steady state the current would be 0. Absolutely wrong statement. But at steady state, the average value of current would be 0. So at steady state, the average value of current through the capacitor is 0. And if the average value is 0, then I can replace the capacitor with open circuited. Why I can replace the capacitor with open circuited? Because what I'm asking you the average value. So basically, I'm taking the average of this particular circuit. What I'm doing, what I'm asking, average value of V0 at steady state. So at steady state, I will take the average value of this circuit. So at steady state, what is the scene? That they are saying that average value across the capacitance or average value through the capacitance is 0. So if I take the average, what does that mean? I can consider capacitor as open circuited. Look, if I had taught you this particular circuit and I would have already said that steady state means capacitor open circuited. That is wrong statement. At steady state, capacitor is not open circuited here. The waveform is pulse. If it was a step or if it was a DC, then I could have said that, okay, at steady state, capacitor will be open circuited. But here, if I take the average of that capacitor, that average of the capacitor is open circuited, not the capacitor is open circuited. Very, very big difference is there. These kind of things are asked in the interview actually. People will say, okay sir, at capacitor you can take, at steady state you can take capacitor open circuited. Absolutely wrong statement. The average value through the capacitor will be 0 at steady state. This is the correct statement. And because of that, when I take the average of the circuit, I can take the capacitor as open circuited. Are you able to understand this point? So this is the point. Okay. So now if I make the graph at steady state, then what kind of graph I will get? Yeah, welcome back guys. Sorry for the interruption. So what we were doing, we were taking the average of this particular circuit, right? So at the steady state, we are taking the average. So at the steady state, capacitor will be open circuited, right? Why it is open circuited? Because average current through the capacitor is 0. So if you are taking the average, that means you need to take the average current. And what is the average current? Average current is 0. Average current is 0. What does that mean? That means open circuited. So at steady state, when you take the average, the capacitor will be open circuited, right? So this is R. Here there is 2R. Here there is 5 volt and here there is V in. What you need to find? You need to find the V0 average. So you are taking the average. So what you are doing? You are taking the average. What you are doing? You are taking the average. So what will be your V0 average? And everything is happening at steady state. All these things are happening at steady state. Not generally, at the steady state. So what will be your V0 average? So that would be, what will be the average value of 5 volt? Average value of 5 volt. If I say this is A, so what is the average value of A? That is A only, no? In signal system, in basics of signal system, we have studied it. What is the average value of this thing? AUT. The average value is half. Here the average value of A is A only. Right? How do we find out? This is a aperiodic, this is also a aperiodic signal. So what do we do? Minus T by 2 to T by 2 xt dot dt 1 by T limit T tending to infinity. So this is the formula. This is how we find it. You can call it periodic as well. A DC can be periodic with any time period. DC is a periodic signal with any time period. That's why it is known as aperiodic, because time period cannot be equal to 0. Here DC is having a time period of 0, because after 0 second, at t equals to 0 you are having a value of A, at t equals to 0 plus you are having a value of A, at t equals to 0 plus 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 you are having a value of A only. So time period of a DC value is 0 and time period 0 is not possible. That's why DC value is known as aperiodic signal, but actually it is always A. So kind of you can say it is periodic, right? The DC has a capability of taking any time period. If I say this is having a time period of 1 second, will you be agree? Yes, because after 1 second, for 1 second it is having a value of A, for another 1 second it is again having a value of A. If I say the time period is 10 seconds, so for 10 seconds it is having a value of A, then another 10 seconds the same thing is being repeated, another 10 seconds the same thing can be repeated. So in signal system course we have studied this particular thing, that DC has the capability of taking any time period, but since the minimum time period is 0, that's why it is known as aperiodic signal. So what is the average value of 5 volt? That is 5 volt only. What will be the average value of input? A very good concept. What do you think? What will be the average value of this particular waveform? 5. People will say that, sir, अरे स्क्रीन को क्या हो गया, स्क्रीन क्यों ब्लैक पड़ गई? Okay, forget about my face, look at the screen. Yeah, so sir, people will say that, sir, 10 into 1, sir, this area divided by the time period. So sir, average value will be 5-fold. So average value of input will be 5-fold. V in, average value of V in will be 5-fold. Wrong. This would have been the average if the graph was like this. Basically, negative part was also there, positive part was also there. Then 10 into 1 divided by 2. But if I have eliminated the negative part, then the average value will be reduced to half. It will be 2.5. Basically, this was having an average value of A. But when I removed the negative part, the average value became A by 2. So if xt is periodic, having the average value of A, then what will be the average value of xt dot ut? That will be A by 2. Look, these are the concept of signal system, but very basic when mathematics also you can tell it. So xt is having average value of A, so xt dot ut will have average value of A by 2. Do you agree to this point? Right? So this will have an average value of A by 2. That means average value of this particular thing will be 2.5. Sir, it would be 10 into 1 divided by the time period, but divided by 2 again. So that would be 2.5. So here the average value, this will be 2.5. So just you need to average out. So here we got the average value 2.5 and there we got the average value of 5. So V naught average, what I need to do? Can I apply this concept 5 into 2R plus 2.5 into R divided by R plus 2R, or you can apply nodal as well. V naught average minus 5 plus V naught average minus 2.5 divided by 2R is equals to 0. So any method you need to apply and you need to find the value of V naught average. So what I am doing, 2.5 into R plus 5 into 2R plus 5 into 2R, 5 into 2R divided by R plus R, that is 3R. So 12.5 divided by 3, 4.16. This will be the answer. Okay, 4.16. Roughly around this will be the answer. Okay, this is wrong. I will change it, but this is wrong. 4.16. This is the answer. I am making the solution before conducting the test. So this is the best thing. This is what I say, like IIT should also do the same. Like if you are framing a paper, then the thing is, if we frame a good question, then there is chances of calculation error. Here I did some error here. Okay, some error was done from my side, so answer was wrong. I guess I took the average value of 5 volt. That's why I get this answer. If I take the average value here 5 volt, so in a hurry a lot of people would have done this error. They would have also taken the average value of 5 volt, then they would get this answer. So these things happen when you frame a question. These things happen, and in gate examination as well, these kind of things happen. Like the people have to give MTA. IITs have to give MTA if they are framing a good question. So, but if you make the solution, no, then you would get to know your error. Like if I haven't made the solution and if I had conducted the scholarship test, then this would go unnoticed and there would be some error. That's why I always say this is the reason why in our test series there are solutions of all the questions. We ourselves make the solutions so that there would not be any error in the test series. The test series should be error free. The question paper would be error free. So this is the thing that I say, like if IITs want their question paper to be error free, then they should make the solution before releasing the question paper. If you make the video solution, if you solve the question on your own, which you have set up from your own side, like you set up a question and then you solve it with the video solution, then you will be able to catch your error. And this happens with us as well. Like we frame a lot of questions, when we put them in test series, we feel like that everything is correct. But when we make the solution, we get to know our error and then we can improve it. This is the way. Like if some coaching institute is listening to this video, then also they can take this particular input from my side, that if you want your test series to be error free, then make the video solution on your own. So this is what we do. So that's why our test series is error free. Yeah, and all these things we study in signal system. So signal system also I am teaching on YouTube, not complete course, but Most of the content is on YouTube. So if you want to take the complete course, then you can come to signal system course as well. So just doing the promotion of my course. So the same kind of enthusiasm, whatever the enthusiasm that you have got in network or analog or digital or in EMFT is also available on free only. So same kind of enthusiasm or even better enthusiasm you will get in signal system, and that's my promise to you, because that kind of intuition I have given in signal system, like frequency spectrum, in Fourier transform, Fourier series. Like people think signal system is mathematics, but it is not mathematics. Okay, we should study it with respect to electronics, not with respect to mathematics. Fourier series, Fourier transform is taught, sorry, not Fourier transform, Fourier series is taught in mathematics as well. Transforms are also taught in mathematics as well. Laplace transform, right? Jet transform, these are in mathematics as well. But if you teach in mathematics, if you teach in signal system, both are complete different thing. One is electronics and one is mathematics. Well, let's not talk about signal system here. So if you want to study signal system from me, then you can study it. And if you want to know that how he is teaching, then a lot of content is there on YouTube. You can check out that content. Well and good. Okay, let's move to the next question. This is a good question. 3 volt step is there and 5 volt DC is there. You need to find the V01 value at t equals to 0 plus. So for t less than 0, what would be happening? That means t from minus infinity to 0, what would have been the case? For less than 0, for less than 0. This 3 ut was not there. For less than 0, this 3 ut was not there. So what was the circuit? R, C. This voltage was 0, R, C, and then there was a capacitor, and then there was this voltage. And this is your V01. Say yes or no. This was the thing, right? Do you agree to this point? Now, what is my matter of concern? My matter of concern is 0 minus. Basically, what is the value of V0 at 0 minus? And let's call it Vc. And what is the value of Vc at 0 minus? Why the matter of concern is 0 minus? Sorry. Why the matter of concern is 0 minus? Because I need to analyze for 0 plus, no? So whatever that has happened at minus infinity, I don't care about that. My matter of concern will be 0 minus. What will happen at minus infinity? The whole circuit will be shorted and voltage will be divided into C and C. So at minus infinity, the voltage here will be 2.5, here also it will be 2.5. But that is not a matter of concern. Matter of concern is 0 minus. So at 0 minus, what is the voltage you are having across capacitor C? Just 1 second, guys. Yeah, chink aa gayi thi actually. Yeah, so at 0 minus, V01 0 minus, Vc 0 minus. So at 0 minus would be the steady state, no? Like 5 volt would have been there from minus infinity to 0 minus. That means 0 minus is the steady state. So at steady state, the capacitor will be open circuited. The capacitor will be open circuited, and this capacitor will also be open circuited. If this capacitor is open circuited and this is the scenario, then there will be 0 current. 0 current through this resistance R. So if there is 0 current through this resistance R, what does that mean? That this voltage drop will be 0. So this capacitor is having 0 voltage. At 0 minus, this capacitor is having 0 voltage. At 0 minus. What about this capacitor? From here 0 voltage, from here 5 volt. So this capacitor is having 5 volt in this direction, 5 volt in this direction, right? So this is the condition at 0 minus. This is the condition at 0 minus. Now at 0 plus, what will happen? This guy will come into action. So at t equals to 0, what is the circuit? At t equals to 0, at t equals to 0, this guy has come into action. So all these circuit, all this everything has been taught by me. Okay, you will never ever find it in any class notes, in any lecture series, whether it is NPTEL or anywhere. You are never going to find these kind of questions. And these are asked in interview as well. These are interview question only. Goats will say that some goats are there on different platforms. They will say that we make you prepare for interview. Send them this question. If they are able to solve it, then I will stop teaching. I should not say like that. I am really sorry. I need to control my words, but I know they are not. They can never ever solve these kind of questions because they have become good and they are never trying to improve themselves. If you improve, I am not saying these things are very tough. Even my students can solve this question. So certainly those educators can also solve this question. But they are having that kind of ego that if new guy is coming, what he will teach, we know everything. So if you are having that kind of ego, then you will never be able to understand these kind of things. So keep your ego down. If some educator is watching this video, keep your ego down and try learning these kind of things. And these things are beautiful, very beautiful. You will love electronics and everyone needs to improve. Even I say that I need to improve. Okay, today whatever I am teaching, after 10 years as well, I'll be saying that I need to improve. Because this is the beauty of teaching. If you keep on improving yourself, you will be doing very good. You will do exceptionally well. But if you feel like you are good, you know everything, then it is what it is, right? Look, now a very beautiful concept will come out of it. A very, very beautiful concept. So this is charged to 5 volt. Now what about this capacitor? This is charged to 0 volt. This is the condition at 0. Now what is the property of capacitor? Property of capacitor is that it doesn't change its voltage instantaneously. So at t equals to 0 plus as well, will you say that it will be having 5 volt only? Because the property of capacitor says that it will not change its voltage instantaneously. But that is true only when there is no impulsive current. So let's make the circuit at t equals to 0. At t equals to 0, if I make the circuit, what is the condition? That here there is 3 volt. Then this capacitor is shorted. This capacitor is shorted. This capacitor will be replaced with a battery of 5 volt. And here there is a battery of 5 volt. Why I did not make the resistance here? Because the resistance is shorted. No? So what do you see here? There is no element, complete short circuit path is there. Everything is shorted. This is the battery, battery, battery. Everything is shorted, there is no element. That means the impedance in the complete path is 0. And if the impedance is 0, then the current will be infinity. So now there is an impulsive current. And if there is an impulsive current, then the capacitor will change its voltage instantaneously. So this is the case of instantaneous voltage change. So now the voltage will be changing instantaneously because there is an impulsive current. And why there is an impulsive current? Because the whole circuit is being shorted. Right? Now either you can say that here I have applied a step. So you can say there is infinite frequency content. Or you can see from here as well that there is 0 voltage across this capacitor. So at t equals to 0 plus, at t equals to 0, there is 0 voltage across this resistance as well. So at t equals to 0, the current through the resistance is 0. So kind of you can assume this resistance as open circuited. At t equals to 0, not at 0 plus. At t equals to 0, there is 0 voltage across capacitor C. The same 0 volt is applied across resistance R as well. Now this resistance R is driving 0 ampere current. And if it is driving 0 ampere current, what does that mean? You can consider it as open circuited at t equals to 0, not at 0 plus. So at t equals to 0, this will be my circuit. 3 UT, capacitance C, 5 volt, and this is charged to 5 volt. Now this was your V01. Now at t equals to 0 plus, what will be the value of V01? At t equals to 0 plus, what will be the value of V01? How will you find it? So this concept I have already taught. Since both capacitors are in series, that means they will be driving same current. Both capacitors are in series, they will be driving same current. They are having the same capacitance voltage. C to C can get cancelled out. That means the change in capacitor voltage, of this one and the change in capacitor voltage of this one will be the same. What I mean to say is that if this has developed delta V voltage, then this will also develop the delta V voltage in the same direction. I am assuming that the current is flowing like this. Current can flow in any direction. I have assumed that the impulsive current has flown in this direction. This current is impulsive. So this impulsive current has flown in this direction. Now both are having the same capacitance value. If they are having the different capacitance value, for that as well I have told the concept. But as of now in this question I am giving the same capacitance value. If it was different, then the ratio would have been C2 by C1. So this concept also has been taught. Okay, you can go and watch out the video of switch capacitor. But as of now, both are having the same capacitance value. So both are developing the same voltage. So if this develop delta V voltage, then this will develop delta V voltage only. So that means after the flow of impulsive current, this guy will have delta V voltage. And what this guy will have? This guy will have, if I write down the voltage in this direction, so already it was having 5 volt, but in the negative direction it was having minus 5 volt, and then it has developed delta V. So this voltage will be 5 minus delta V. Are you able to understand this point? So this is the value at t equals to 0 plus. This is the value of capacitor voltage at t equals to 0 plus. So what you are getting? 3 minus delta V. What I am doing now, I am applying the nodal analysis, or you can say KVL I am applying. So 3 minus delta V minus, wait a second, it was delta V minus 5, really sorry, it was delta V minus 5. because it was having minus 5 voltage and delta V was developed. So delta V minus 5. So 3 minus delta V. Look, you might not be able to understand all these concepts very easily. You have to do the course on transient analysis from YouTube. I have uploaded everything on YouTube. So if you do from there, then you will be able to understand all this concept. Otherwise, it will be very difficult in one lecture, in one solution video, it would be very difficult to understand all these concepts. Minus delta V minus 5 is equals to 0. Started from here, 0, 3 minus delta V minus 5 is equals to 0. So 3 minus delta V plus 5 minus 5 is equals to 0. So delta V is coming out to be 1.5. So delta V is coming out to be 1.5. So 1.5 minus 5, that would be equals to minus 3.5 volt. So what is the value of this was your V01, right? This was your V01. So V01 at t equals to 0 plus is minus 3.5 volt. This is the answer. This is the final answer. The value answer will be minus 3.5 volt. This is how you need to analyze it. Otherwise, I have told you a shortcut as well. 3 minus 0. Basically, you would have started from here. 3 minus 0 plus 5 minus 5 divided by 2, 1.5. So everyone will get 1.5. So all these shortcut, everything I have explained in a very good manner. For that, you have to watch comprehensively. Here I am just giving the solution. Those who don't know anything, they would also be able to solve in this manner. Right? A very good interview question. In a IIT Madras interview, this question was asked last year. And this was already there in our notes. The two same questions were there in our notes. Same analysis was there. Okay. Yeah. So answer would have been minus 3.5 volt. So this is the way you need to analyze it. Here you cannot apply Laplace. Can you apply Laplace for this particular thing? No. Right? But Laplace analysis will be very difficult in this circuit. Only time domain analysis you need to do. And this kind of time domain analysis will be used here. Okay, yeah, it might happen that you are not able to understand all these things. You will think that, sir, how we will think all these things in the examination hall. So study it comprehensively in a good manner, then you will be able to think all these kind of things in the examination hall. Applied input is 3 volt. Then switching conditions are given. So from 0 to 2 seconds, S1 is closed and S2, S3, S4, S2, S3, S4 are open. So in that manner, switching condition is given. You need to find the value of I1 at t equals to 5 seconds, and then you need to find the value of I2 at t equals to 10 seconds. Again, would be very difficult if you haven't studied this concept. If you have studied it, it would be easy, but if you haven't studied it, it would be difficult for you. I cannot explain all the things in this particular circuit, or I will try to explain all the things. So first, let's get started. First, S1 is closed for 0 to 2 seconds. So all these are open, that means this circuit will not come into action. So for 0 to 2 seconds, only this much circuit is in the action. A constant voltage is exposed to the inductor. A constant voltage is exposed to the inductor. So how much current it will take? Let's call this current as I0. So I0 will be, what is the equation? Current, inductor current, that is 1 by L V dot dt. Since this is coming at t equals to 0, basically the switch is being closed at t equals to 0. Although this is a DC, but since it is closed at t equals to 0, this has become a step. So this voltage is step only. So although I should write minus infinity to t, but since it is coming into action at t equals to 0 seconds, so I can take from 0 to t. And there is a constant voltage, so it would be 3t by L. What is the value of L? Yeah, L is 1 Henry. It is given here. L is 1 Henry. So the current is 3t ampere. So it is there for 2 seconds. That means the value of current I0 at 2 seconds would be 6 ampere. Now at 2 seconds, what happened? This is gone and this has come into action. So at 2 seconds, from 2 to 4 seconds, what will happen? Now this inductor, this particular inductor, L inductor, was driving how much current? 6 ampere current in this direction. This was driving 6 ampere current in this direction. This inductor L. This was driving 6 ampere current in this direction. Now the previous part is gone, ahead part is gone. This part is gone, next part is gone. Now this is the scenario, 6 ampere current. What is the initial current in this inductor? That is 0. So this inductor is saying that I will drive 0 ampere current, and this inductor is saying that I will drive 6 ampere current, because what is the property of inductor? That it will not change its current instantaneously. It can change its current instantaneously only when there is impulsive voltage. If there was impulsive current in the capacitor, it was changing its voltage instantaneously. If there is impulsive voltage across the inductor, then it can change its current instantaneously. If you are not able to think this much, then what you will think? That this inductor is saying that I will drive 0 ampere current, and this inductor is saying that I will drive 6 ampere current. Now from here you will say that 6 ampere current should flow, but this guy is saying that 0 ampere current should flow. So where will the other current go? KCL is being violated here, right? One is saying 6 ampere, one is saying 0 ampere. So you are saying that 6 ampere should current, 6 ampere current should come, but this inductor is saying that 0 ampere current would be there. So there is something wrong. That means here surely it will be the case of impulsive voltage. That means here instantaneous current change would be there. And whenever there is instantaneous change, that means there will be flux conservation. In case of capacitor, there will be charge conservation. In case of inductor, there will be flux conservation. So how will you apply flux conservation? Flux conservation. So that would be L1 I1 plus L2 I2 divided by I1 plus I2. So this 6 ampere current will make sure that this guy also gets some current, and that current would be equals to, both of them will be having the same current in this direction, both of them will be having the same current, and all these things will happen instantaneously. Just as you close the switch, at that time only it will happen in 0 second. So L1 I1, 6 into L1, initial current was here L into 0 divided by, L1 plus L2, L1 plus L2 divided by 2L. So it would be 3 ampere. So this was driving 6 ampere current, but instantaneously there will be change of 3 ampere. So all these things has happened at t equals to 2 plus only. So this is there just to confuse you, 2 to 4. Okay, I could have given it to 2 to 2.5 as well. I could have given it to 2 to 2.01 as well. Are you able to understand this point? So all these things have happened instantaneously. So instantaneously the current has changed from 6 ampere to 3 ampere. But the point is, this current is flowing in this direction. Okay, it was 6 ampere, but now it is 3 ampere. So till 4 seconds we have analyzed it. Now from 4 to 6 seconds what will happen? This switch is closed. From 4 to 6 seconds what will happen is that this switch is closed now. But what is the scene? That this inductor is driving 3 ampere current in this direction. In which direction? In the upper direction, 3 ampere current. This is R, this is L, this is L. The switch is closed at 4 seconds. So now we are going to analyze from 4 to 6 seconds. 4 to 6 seconds. So let me make this switch closed only. So now this is the circuit. Okay, this is the circuit. 3 ampere current is there. So what this guy will say? That I will drive 3 ampere current. What this guy will say? I will drive 0 ampere current. Or in the upper direction you can take. In this direction only you will take 0 ampere current. So this guy is saying that I will drive 3 ampere current. So 3 ampere, 3 ampere, 3 ampere. But this is saying that I will drive 0 ampere current. Again there will be instantaneous change. Because KCL is being violated. 3 ampere, 3 ampere, 3 ampere, 0 ampere, 0 ampere, 0 ampere. KCL again is being violated. Again there is instantaneous change. So this 3 ampere will make sure that this guy gets something. And how much it will get? 3 into L plus L into 0 divided by L plus L. That means instantaneously there will be a change in the current. Instantaneously this current will become 1.5, and same will happen to this one as well. So instantaneously this current will become 1.5, and then this current will become 1.5 ampere. So the current, this current I am calling as I. So current I at 4 plus instantaneously it has become 1.5 ampere. Where it will go at steady state? Where it will go at steady state? At steady state what will be the condition? Both inductors will be shorted. At steady state both inductors will be shorted. If both are shorted, that means there will be 0 voltage across resistance R. That means this resistance will drive 0 ampere current at steady state. This resistance will drive 0 ampere current at steady state. So if there is 0 ampere current through this resistance at steady state, that means what will be the current through the inductor at steady state? That will also be 0. What did I say? At steady state, inductors will be shorted. If inductors are shorted, that means there will be zero voltage across the resistance. If there is zero voltage across the resistance, that means there will be 0 ampere current through the resistance. Since L, and R, all these are in series. So that means if there is zero current through the resistance R, that means there should be zero current through the resistance L and L as well. What does that mean? That value at infinity will be 0. So basically, what will be the condition of I? So what will be the equation of I? That would be 1.5 e to the power minus t by 2. Now what will be the value of tau? You can directly see both of the inductors are in series. So 2L by R, 2 by 1. So value will be 2 e to the power minus t. So you need to find from 4 to 6 seconds. 4 to 6 seconds. So in the window of 2 seconds, how much current it will lose? This much current. Window of 2 seconds. So this much current it will lose, 1.5 by E. So this is the value of I. But what is the direction of I? This is the direction of I. Upward direction. But in which direction I am asking? In the downward direction. So I1 is equals to minus I. Those who are good student of PrepFusion, they would have solved it. But there is very high chance that you would have put positive answer. And that is costing you 10 marks. Okay, I have sympathy for you guys, but it is what it is. Answer would be negative. Look, 95% of the students would not solve it. I know this particular question will not be solved by anyone. Only 1 or 2 students will be solving it, and in a hurry, the negative sign can be an issue. Okay, so answer would be minus 1.5 by E. So let's do the calculation. I hope the calculation is correct. Just for checking the answer, 1.5 divided by roughly around 2.7, 0.55, right? Alright. 1.5 by E. What is the answer I am telling? Okay, I1 at 5 seconds I am asking. Oh, really sorry. I1 at 5 seconds. I am asking I1 at 5 seconds. That means this will be the window of 1 second. So this will be e to the power 1 by 2. Okay, 0.5 plus minus into 1.5. So it would be 0.9. Yeah, okay, fine. So this answer is 0.9, but the value of I1 would be minus 0.9. Okay. But now we need to analyze from 6 to infinity second. We need to analyze from 6 to infinity second, right? So at 6 to infinity second, what will happen? Now this switch will come into action. Basically, this is the condition that there is an inductor, then there is a resistance, and then there is another inductor. This is the condition now. L, R, L. This is the condition, okay? This inductor will say that I am driving 0 ampere current. How much current this inductor is driving? That I need to know. Basically, here in this inductor, there is some current, right? This particular inductor is coming into action now, right? This particular inductor. Basically, this inductor is coming into action now. So, how much current at 6 seconds this is driving? At 6 seconds, how much current this inductor is driving? That I need to know, right? So, whatever the current this I1 is there, the same current is flowing here as well, no? So, basically, I need to find the value of this I at 6 seconds. Whatever the current that is there in this inductor, the same current has to be there in this inductor as well. Do you agree to this point? Yes. The same current has to be there here as well. Do you agree to this point? Absolutely, I agree to this point. So, I need to find at t equals to 6 seconds. The equation is 1.5 e to the power minus t by 2. 1.5, the window is of 2 seconds. Value of tau will be 2 only. So, 1.5 by E. 0.55. 0.55. So, the current is flowing in the up to down in this direction 0.55 ampere at 6 seconds. At 6 seconds. So, at 6 seconds, the current is flowing from up to down. This is the current at 6 seconds. At 6 seconds, the current is 0.55 ampere. Do you agree to this point? Are you able to understand these points? 3 ampere, from 3 to half it became, then 1.5 is reducing to 0. We had 3, then it became, instantaneously it became 1.5, But then we go to know that from 1.5 it will go to 0. So 1.5 e to the power minus t by tau. Tau I know. I have a window of 2 seconds. At 5 seconds, question was asked, that answer I have given. But I need to analyze the circuit from 6 to infinity now. So after 2 seconds, where it would have been reduced? 1.5 by E, and that value is 0.55. So now the condition is this is driving 0.55 ampere current. And how much current this guy is driving? This is driving 0 ampere current. Just let me know, KCL is being violated or not? No, it is not being violated. Why is that so? Because 0.55 ampere current would come here, 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 here. Then it will say that this side there is 0 ampere current. And this guy will say that this is the resistance. It can take any amount of current. So this 0.5555 ampere current is going here. So resistance can take up the current now. So now there will not be any instantaneous change. The 0.55 ampere current can flow through this resistance. So how much voltage drop it will give here? This kind of voltage drop it will give here, right? 0.55 ampere current is flowing. So 0.55 into R, this voltage drop it will give here, and the same voltage drop will be coming to this inductor. 0.55 into R. And if there is some voltage across the inductor, what it does? It drives some current. If this is the voltage, then it will drive the current in this direction. So if there is some voltage across this inductor, what it will do? It will drive some current. So this inductor will start driving some current now. Are you able to understand this point? This inductor will start driving some current now. So slowly it will start driving the current. At steady state, what will happen? Both inductors will be shorted, right? At steady state, both inductors will be shorted. That means there will be 0 voltage across this resistance. If there is 0 voltage across this resistance, what does that mean? This resistance will drive 0 ampere current. So at steady state, this resistance will drive 0 ampere current. Does that mean that these inductors will also drive the 0 ampere current? Here, if this was driving 0 ampere current, then at steady state, both of the inductors will drive 0 ampere current. That was certain. Why it was certain? Because all were in series, right? But if I am saying at steady state, this resistance is driving 0 ampere current. So is it necessary that both of the inductors will drive the 0 ampere current? No. Basically, whatever the current that is flowing here, in this resistance, there will be 0 ampere current. The same current will be flowing through this inductor. So if this is the circuit and I say that at steady state, resistance is driving 0 ampere current. At steady state, resistance is driving 0 ampere current. That doesn't mean the inductors will be driving 0 ampere current. It means that inductors will be driving the same amount of current. So if I write down the current in this direction, I call this current as I alpha. Okay. So I alpha initially, that means at 6 seconds, it was 0. Why it was 0? Because this 0.55 ampere current has all the path to flow from resistance R. So there was no instantaneous change. So it was 0. But at steady state, what will happen? At steady state, both will drive the same amount of current. So slowly the current is being built up in this inductor. And we have checked it as well. Because whatever the voltage that was there across the resistance R, the same voltage is exposed to this inductor. So slowly the current is being built up in this particular inductor. So whatever this current was there, this current is being reduced and this is developing some current. There will be one time where both of the inductors will be driving the same amount of current and the resistor will have 0 ampere current. And if the resistance is having 0 ampere current, that means it is having 0 voltage across it. And if there is 0 voltage across it, if there is 0 voltage across the resistance, that means there will be 0 voltage across the inductor as well. And if there is no voltage across the inductor, that means it will not drive any further current. If you give current to a capacitor, then it will develop voltage. If you give voltage to an inductor, it will develop some current. Give a voltage to inductor, it will develop current. Give current to a capacitor, it will develop voltage. So the same thing, 0.55 ampere current was there in this inductor. Initially, inductor was driving 0 ampere current. Then there was some voltage drop here. Because of this voltage drop, this inductor started driving some current. Slowly what is happening? This inductor has been building up some current. And slowly the current in the resistor is going down. At steady state, the current in the resistor will be 0. 0 current means there will be 0 voltage drop across the resistance. And if there is 0 voltage drop, that means there will be 0 drop across inductors as well. So this is the steady state. So at the steady state, both of the inductors will be driving the same current. whatever the current that has been set up, they will be drawing the same current. And what will be the value of that current? You can again apply the flux conservation at steady state. What was the initial current? 0.55 L. 0.55. What was the initial flux? Sorry, 0.55 into L. And here what was the flux? 0 into L divided by L plus L, 2L. So steady state value will be 0.55 by 2. So this is the condition of I alpha. So I alpha at steady state, I alpha value at steady state is 0.5 by 2 e to the power t by 2. What is the value of tau? L and L are in parallel. So tau will be L by 2 divided by R. So what is the value of L? The value of L is 1 Henry. So it would be 1 by 2. So value of tau is 0.5. Value of tau is 0.5. 0.5 by 2 e to the power minus t by. How much window they are asking? They are asking the value at 10 seconds. Value at 10 seconds. Value at 10 seconds. That means the window of 4 seconds. Because from 6 to 10 there will be a window of 4 seconds divided by 0.5. So what is the answer you will get? Nearly around 0.55 by 2 only. Because if time constant is 0.5 second, then in 5 tau almost steady state will be reached. That means in 2.5 seconds the steady state will be reached. But we are having a window of 4 seconds. That means steady state would have been already reached. So roughly around this answer you will be getting, or you can put in calculator as well. What you will be getting? 8 plus minus e to the power minus 1. So you can see 0.9999 into 0.55 divided by 2. So you are getting 0.274. 0.274. This is the answer you are getting. So I alpha at 10 second is 0.274 ampere. So this current is flowing from down to up, 0.274 ampere. So from up to down, how much current is flowing? From up to down, how much current is flowing? The negative of that. So answer would be minus 0.274. So what would be the answer? Minus 0.274. I know this question paper was tough for you. I know all these things were tough for you. But this is what I wanted to deliver here. This is what I wanted to check, that actually if people are studying from PrepFusion or not. I am not defaming any coaching institute here. All coaching institutes are good. Okay, everyone is good. But the best platform is PrepFusion. It's not that here I am asking some questions which is based on calculation or anything out of the box. No. Look, what people can do is that they can frame irrelevant question. Completely irrelevant, high calculation is there, nothing, no concept, nothing. And then they can claim that as if they are the best. But here you would see everything is based on your brain. Very rarely you need to do calculation here. Very rare calculation is there. Like no Laplace, nothing. Every question is based on the analysis. No calculations, nothing. Okay, and this is how we teach. This is how we teach the subjects on PrepFusion. This is the quality of this platform, and those who have studied it, they would know. Be it network analysis, analog, digital control, signal, EMFT, communication, even aptitude or mathematics or EDC. This is how the things are taught, and this is how the things should be taught. So nothing against any organization. It is just that I wanted you to know that whether you are studying from this platform or not, and if you are studying, are you able to understand these kind of concepts or not? Are you able to solve these kind of questions or not? Because not today, tomorrow these kind of questions can be asked in your examination. And you try applying Laplace in this question, you will keep on applying and you will not be able to solve. Like IITs are asking these kind of questions in their interview. So if those IITs frame the GATE paper, then surely they can ask, no, these are also interview question only. Okay, here there are three different circuits basically. What interviewer would do? First he would ask this circuit, then he would ask this circuit, and then he would ask this circuit. So three different circuits are there. I made them in one circuit only, and then I asked you this numerical question. They can also frame the same question, and they can frame the same question with respect to capacitor as well. But the capacitor question I have uploaded already on Telegram group. That's why I did not ask here, because those who have already seen that capacitor question, for them it would be easy. But now I replaced capacitor with inductor. Now analysis of inductor is a bit tougher than capacitor, right? And this is the beauty. With respect to capacitor, this circuit has already been asked in the gate examination. With respect to capacitor, this circuit has also already been asked in the gate examination. Now with respect to the capacitor, this circuit can come, or with respect to the inductor also this circuit can come. Are you able to understand this point? Okay, and people solve that particular question with Laplace transform. And do you really think you will be able to apply Laplace transform in the examination hall? There will be so much pressure on you, and if you apply Laplace, one current polarity is gone and your complete solution is gone. Then you apply Laplace, then you calculate inverse Laplace, then you get the equation in exponential. After that you put the values. How much time it will take, and everything will be messed up. This is how the examination is messed up. People will say that, sir, I know everything, but how my examination got messed up? Because you did not understand the things in a good manner. आप मजदूर नहीं हो ना, you are an engineer, right? In JEE you could have studied in any manner, but when you are preparing for engineering examination, you are supposed to be an engineer. An engineer do not apply mathematics. A mathematician does. If you are doing a PhD, you can apply mathematics, but engineer will just see the circuit and he will tell what is happening in the circuit. That's it. So if I see the circuit, okay, first current will be built up linearly, then whatever the current has been built up will be distributed in L and L. Now whatever the current is there, it has to change instantaneously, but it will try to go down to 0. But in between, whatever the current has been set up, that will be fed to the inductor L. In this final inductor, it will be set up. And that's it. This is the analysis of this circuit. But if you have the good concept, if you have spent a good enough time, then you will be able to analyze in this manner. Okay, so I hope you attempted this test series in a good manner, and I hope you enjoyed this test series. That was the main motive, that you would enjoy the level of problems. Okay, so whatever the scholarship that you have got, in some time only you will get the scholarship code. You can apply the code and you can study from us. If you are studying from some other platform as well, I don't have any issue. I will always have your support. I will always have my support to you guys. Okay, I will always support you guys. Whatever the query that you are having, you can put in Telegram. I always try to answer all the queries. Okay, yeah, that's it. Thank you very much.